So let's work through an example where we're actually trying to graph a function. So the one I picked for our first example here is f of x is equal to x to the 3 minus 5x squared. And this is the template that I like to use to help to graph a polynomial. And I'll make sure that there's a copy of that available for you to use. But I like to kind of go through it because it helps me remember sort of all the different pieces that I can use to help me graph this polynomial. Of course, on a test, you probably won't have this template with you, so you'll have to sort of have these things memorized. But for now, it's kind of a nice methodical way to actually go through and figure out some of these things. So the highest power of x, the degree, that's the first thing it asks for. The highest power of x here is 3. So let's write that in. That's an odd power, okay? And the leading coefficient here is 1, which is a positive value. Okay? And if you watched the last video, if I have an odd degree and a positive leading coefficient, right, that means that it's going to start, let me draw a little picture, right? We know it's going to look something like this, and how much it wiggles and dips here in the middle, we're not exactly sure, right? But it's going to start in the quadrant to 3, which is the bottom left, right? Okay. And it's going to end in quadrant 1, which is the top right. Okay. And so already just from looking at sort of the degree and the leading coefficient, I can already know a lot about sort of what the behavior of this is going to look like. But there are a few more things I can do to help make my graph more accurate. So the first thing here is we can solve for the y-intercepts. It says set x equal to 0 and solve for y. So if I do that, I'd have y is equal to 0 to the 3 minus 5 times 0 squared, which is of course just 0. Okay, so that y-intercept is at 0. And how about I just jump down, okay, right to the graph. Let's not forget to draw that on. Let's draw that, oops, that y-intercept on right now. There it is. There's our y-intercept, just so we don't forget. Okay, the next thing that you might want to do are these x-intercepts. Okay, so it says we're going to set y equal to 0 and solve for x using factoring. So let me plug in, this was x to the 3 minus 5x squared. Now it says that we're going to want to factor. So in this case, we're lucky. Both of these terms have some x's in them. In fact, we could factor out 2 of them. They both have at least 2 x's. So if I factor out 2 x's, I'm left with 1x from that first term, and I'm left with minus 5 from the second term. And so from there, right, I know that what's going to make this factor equal to 0 is x is equal to 0, right? And what makes this factor equal to 0 is x is equal to 5. So those are my 2 x-intercepts. And heck, why not? Let's go down and plot them right on. So 0, we already had that one, but let's plot this one over here. And I best label it here. This is 0 and 5. Okay, so we've plotted those on. Now, the next thing I've put on here is to classify the x-intercepts. And this is sort of an optional step, but I like it because it helps me. So what we're going to do is we're going to go through and we're going to look at the x-intercepts. Okay, and so this x-intercept of x, it's associated with a 2 here, right? That's an odd or an even number, right? So that means that there's going to be, I'm sorry, this is jumping all around on me. That means that this x is equal to 0. It's going to bounce at x is equal to 0 because of that 2, right? Anytime it's associated with an even power, it's going to bounce. Whereas x is equal to 5, we didn't really write it in there, but there's sort of a missing 1 there. So that's an odd power, so it's going to cross through at x is equal to 5, and we can use that to help us. Okay, so we better use our number line. Okay, so I guess I should have said on here that we should plot the x-intercepts, so maybe I'll write that in here, and I'll add that to my template. Plot the x-intercepts first. So the x-intercepts were at, let's see, 0 and 5, right? Okay. And we knew that the 0, 1 is a bounce, and the 5 is a cross. Okay. Now it says, in each interval, determine whether f of x is positive or negative. So you're going to go through and pick, your favorite value in that interval. So I don't know, some number between negative infinity and 0. Let's pick -1. Okay. And I always like to take -1 and plug it into the factored version right here. Okay. Because then I don't have as much work to do, right? -1, square it, it's a positive number. -1 minus 5 gives me a negative number. So I really only have to do the sign analysis. I don't actually have to go through and work out exactly what number it is, right? But I've got a positive times a negative. So in this interval here, it's going to be negative, okay? Now I know, because it's going to bounce, that if our function is negative, meaning it's coming up here sort of below the x-axis, it's supposed to bounce. So it's supposed to go back down and keep being negative. So I kind of know that, but let's go through and pick some value of x just to be sure. So I don't know, our favorite value of x, doesn't matter which one we pick between 0 and 5. Let's go with 1 again, positive 1 this time. And if I plug in positive 1, right, positive 1 squared is a positive. 1 minus 5 still gives me a negative number. So just like I said before, right, this should give me a negative number, and it does, right? So at the bounces, these numbers should, or these signs should be the same. So we've got that it's sort of coming up negative. Our function is below the x-axis. Our function is negative. It's going to bounce and keep being negative, right? And then it's going to have to go back up here, and we're going to have to see what's going to happen. Now, it does say it's supposed to cross, so it sort of seems like it would come up here, right? But let's go through and pick some value of x in that interval and just see what happens. So pick, let's go with 6. And if I plug in 6 up here, 6 squared is positive. 6 minus 5 gives me a positive. Positive times a positive makes this positive. So that sort of makes sense. So from there, now I can use all of that information to sort of go in and draw this graph. So remember, we said it was negative on the interval between negative infinity and 0. It's going to bounce there at 0. It's going to go back down to negative, and then it's going to come back up through 5, cross, and become positive. Okay, so that's sort of a rough sketch of what that graph is going to look like. Okay. And again, remember, if I go back up, that sort of matches up with what we thought was supposed to happen with this end behavior. We said it was going to start in the bottom left and end in the top right. And that's sort of what happened here. Okay. And in terms of a graph, for now, that's the best that they're going to, that's a really good graph of what I think they would expect you to want, be able to do on a test. Now, if you did, students always ask me, well, how do I know, like, how far down to draw this bump? Right? Or how do I know if I'm supposed to be doing that in the right spot? And that's a question that calculus is going to help us answer. So I'll try to make some more videos for polynomials when we have a little bit of calculus so that you can go through and see if those are going to work. But we still are able to get a pretty good graph, right, of just the general shape without knowing any calculus at all.